like, share, subscribe.
Hey y'all, welcome back. Tonight's homework is all about graphing linear inequalities, so let's go ahead and get started. Number 1 says determine whether the points are solutions to the inequality. So remember that solutions, in order to be a solution, a set of coordinates, an x and a y, have to be able to be substituted back into the equation, or in this case the inequality, and make it true. So all we really need to do here is look at this original inequality and substitute in 0 for x and 1 for y, and just see if it's true. Is this expression on the left going to be less than 6? So let's go ahead and find out. So I'm going to, instead of having x here, I guess I'll just rewrite it just so you can more clearly see what the substitution is. For x, I'm going to plug in 0. So I can put 0 here, and I'm going to put 1 here. And we're just going to evaluate this. 0 plus 3 times 1. 3 times 1 is just 3, and then plus 0 is just 3. So we get 3 is less than 6. That is true. Okay, so since that's true, since 3 is less than 6, then 0, 1 is a solution to the inequality. I'll say yes, 0, 1 is a solution. Okay, a solution just means that it makes the inequality true, and this one does. 3 is less than 6. So now we'll try the next one here using the same inequality, -2, 4. It's the same exact process here, so I'm just going to go ahead and copy all this, and instead of replacing x and y with 0 and 1, we are going to replace x and y with -2 and 4. I'm going to put -2 here in for x and 4 in for y. See what this thing equals. So let's see, 3 times 4, this would be 12. And 12 plus -2 would be 10. Now, 10 is obviously not less than 6. Okay, so that means that 2, 4, I'm sorry, -2, 4 is not a solution. So no, -2, 4 is not a solution. Go ahead and box our answers here just to make this official. Let's see here. Go. Okay, part C, 1, 2. Same equation, same process, really just practicing substitutions here. Making sure that you understand what it means to be a solution. So we're going to plug in 1 into x, 2 into y. Let's see if this one works. Doesn't really look like it will, because 3 times 2 is going to be 6. And 1 plus 6 is 7. So this is going to be false also. This is going to be a non-solution. So if we were to graph out that inequality up here, these points that are not solutions will not be in the shaded region. Okay, 0, 1 would be in the shaded region, but -2, 4 and 1, 2 will not be in the shaded region. So we're going to say no, 1, 2 is not a solution. Box our answer, and that's it for this first section. Let's take a look at the next section. It says graph the inequalities. So these first two are just one variable inequalities, and you can actually get away with graphing these on a number line, but since we have the Cartesian plane here, let's go ahead and show you how that works. If I'm going to graph y is greater than 3, what I want to be thinking about is, like, where is y equal to 3? Right? What does this graph look like? Because I'm going to graph that line and then use the inequality to decide where to shade. Now this is a strictly greater than symbol, so we are going to be using open dots and dotted lines rather than solid dots and solid lines to indicate that the points on the line are actually not solutions, only the points in the shaded region. So y equals 3 is right here. I'll go ahead and draw that. We'll draw a line here. Let's make this a dotted line. Yeah, and it goes through y equals 3, so that's going to be right here. I'll do a little open dot here at 3. Oh, I don't know what's going on with that head dot there. That's getting covered up. Kind of weird. Anyway, this is supposed to be like a little circle here. Can I draw it for that? Weird. Okay, anyway, let's go ahead and draw our line here. It's going to be a dotted line. And it's just going to be this horizontal line right here. That is where y equals 3 would be. It's dotted because it can't actually be equal to 3. This y equals 3 is really just to help you figure out what the line should look like. We don't really need that anymore. Now this says y is greater than 3, meaning that all the solutions will exist up in this region. So what you want to do is you want to shade above the line. Let's see if we can't get a good, this really big and maybe not so transparent so you can see the graph, the grid rather. Or yeah, let's just, so there we go. So we'll just shade in this area where y is above 3. So I'm trying to get right up to that line, but really just trying to show the line also. Any point up here would be a solution because the y coordinate would be bigger than 3. Now, if you have an x instead of a y, we talked about in the earlier this unit where if you have x equals a number, then it's going to be a vertical line rather than. So yeah, so if you have a x versus a y, you're going to have a vertical line versus a horizontal. So this one is going to be solid though because it could be greater than or equal to. So when we draw that line, we want to make sure that it's actually solid. So at -2, we do have a point right there. So let's go ahead and plot that in and we'll make sure it's filled. At x equals -2, it's going to be where we're going to draw this. There we go. And then here's our line. Vertical line. And we want to shade where the x coordinates are greater than or equal to -2. So bigger than -2 is going to be to the right. You're going to shade to the right over here. Shade all this in. Be a little messy there. We can be a little cleaner about how we shade here. It's not the best shading job, but it gets the job done. Anyway, we're shading to the right of this line. Okay, it really should be nothing left here. Really want to make that obvious as possible. All right. Well, hopefully you kind of get the idea here. This doesn't look great, but if you're using a pencil, it'll probably look a lot better on your paper. Okay, so yeah, anyway, that's what those two should look like, roughly. Now, those were sort of our special cases where we have horizontal and vertical lines. But as we've seen, we can also have just regular lines in that mx plus b format. And so this is going to be a little practice graphing those lines. So let's go ahead and graph this one. This is y, the line that we're going to draw here would be like in this y equals mx plus b format, where the slope is 5 and the y-intercept is 0. So this number would be 5, this number would be 0, that's why you don't see the plus 0. So that tells us that our y-intercept is going to be at 0. I am going to have open dots here because I don't want to actually include the points on the line. Okay, so my y-intercept is 0. And then the slope, again with the circle getting deleted there. I don't know what's going on there. A little weird. Anyway, so if I scroll down, does it come? No. Doesn't really like the top half of that circle for some reason. Seen that before. Image is kind of glitching out there. Oh, that's what it is. Okay, I think I see what's happening here. Set to dotted line. There we go. Now we should get the whole. All right, troubleshooting live here for you. There we go. Much better. Okay, those were kind of bugging me. All right, so anyway, our slope is 5. So we're going to go up 5 over 2 to find the next point. Up 5 over 1. Did you say up 5 over 2? It should be up 5 over 1. Up 5 over 1. And then I can continue that pattern backwards to find more points on this line. And here we go. So these points are going to line the line. These are not going to be solutions because y has to be less than the points that are on the line, not on the line. And so let's go ahead and draw our dotted line here. Oh, that's not going to work. That should be dotted. Where we'll get this right for you here in a second. There we go. Okay, that looks nice and dotted. Okay, so there's our line. And now, since it says y, well, what did it say again? Y is less than, so we're going to shade downward. So basically just pick any point and just imagine like going directly down, falling down. And that's going to show you which side of the line to shade on. Yeah, we'll go ahead and shade on the downside here. You know, the line is pretty vertical, so it could be a little tricky to think about like up and down. It looks more natural to say left and right, but really you should be thinking up and down because it says y is less than, and the y values go up and down. I'm going to shade this whole region, and so any point in this region is going to be a solution. Number 5 is y is greater than, so that means we're going to shade up 2x plus 3. So the y-intercept on this one's going to be 3, the slope is going to be 2. So let's go ahead and plot that y-intercept at 3. Slope is 2, so I'm going to go up 2 over 1. It's going to have a bunch of points here. Be able to fit a lot. Really don't need to put all these on here, but just to kind of get the idea down. I'm just going to do one more here. Do this one, and then I'll just let the line kind of do the rest of the work for me. Okay. Here we go. I'm going to go through points here. That looks decent enough. Go ahead and draw the line. Not like that, though. Let's color that in. So it says y is greater than. So that means that we're going to shade up. Less than you shade down, greater than you shade up. So that means the shaded region is going to be this region. Any point in the shaded region is going to be a solution to the inequality. All right. Yeah, there's number 5. Take a look at number 6. Looks like, you know, from here on out, just a lot more inequality stuff. Number 6 has a y-intercept at -5. Now, the inequality symbol here is less than or equal to, so we are going to do a filled-in dot with a solid line. And we're going to start that line at the y-intercept, which is -5. Here. The slope here is 1/2, so we're going to go up 1 over 2, rise 1, run 2. And I'm not going to do every single point on here, but just enough to really get a good idea of where this line's supposed to be. Probably enough. That's probably more than enough. Let's go ahead and draw the line. And it is going to be solid. Hopefully this is still set to solid. Nope, it is not. There we go. And then really just trying to hit those points correctly. Make sure I go through all of them. And then go ahead and draw the line. On some little arrows here. Okay, so remember when when you graph these lines, if you graph a solid line, it's because it could be less than or equal to. The equal to part of it's kind of the important part there. So that indicates that the points that are on the line in this case will be solutions. So that's a little different than your dotted line. The dotted line, when you draw a dotted line or a dashed line, the points on the line are not solutions, but in this case they are. So like, 6, -2, for instance, would be a solution here, where something like 1, 5 would not be a solution here. You'd have to be in the shaded region. Now, if the shaded region contains solutions as well, that's going to be true regardless of the symbol. Yeah, all the points in here will also be solutions. Now, number 7 is starts in standard form, and I think this will be a lot easier to graph if we put it into slope-intercept form. I'm going to subtract 3x from both sides here to rewrite this equation. If I subtract 3x from both sides, I'm going to be left with y is less than or equal to -3x plus 4. I just think it'll be easier to plot this if we do it in slope-intercept form. So if you ever see an equation that's not in slope-intercept form, go ahead and put it in there. I think it'll help. Okay, so our y-intercept here is at 4. There. And the slope is -3, so I'm going to go down 3 over 1. Again, we're doing closed dots here because of the equal to. I want to indicate that the points on the line are solutions in addition to that shaded region. Go ahead and draw this. Oh, that's going to be a little thick there. We don't need it that thick. Right on there. Okay, that looks pretty good. Okay, so here's my line. This one says less than or equal to. So less than indicates that the solutions are going to be points where the y values are less than those that are on the line. In other words, they're going to be below the line. I'm going to shade this whole region here. You'll see, I just pick a point. Say less than is going to be below. Shade this whole region here. Go, just kind of fill everything in here. Okay. It doesn't have to be perfect. You can see I'm being a little sloppy with some of these, but you just really want to communicate the idea that you know which side of the graph should be shaded in, which one contains all the solutions. Okay, so there's number 7. Let's move on to the next one. Just kind of more the same here. It's another one that's not in slope-intercept form, so let's modify this a little bit. We're going to subtract 2x from both sides to give me 5y is less than or equal to -2x minus 10. And then if I divide everything by 5, it is unfortunately going to cause this slope to be a fraction. This is not that unfortunate. But the y-intercept here is 10 divided by 5 is going to be 2, so -2. So it's less than or equal to, meaning we are going to use closed dots, solid lines here, to indicate the points on the line are solutions. And let's go ahead and start with our y-intercept at -2. What's going on here? Why isn't not saving my transparency setting? There we go. And then I'm going to go down 2 over 5, be right here. And I can't really fit a ton of points here, so I'm just going to go all the way to the edge and back. Go up to the left 5, expecting a downward slope because the slope is negative. Notice how the line is going down from left to right. Go ahead and draw my line here. There's the line, okay? So this one says that y is less than or equal to this expression. So we are going to shade down. All the points in this region and those on the line are solutions to the inequality. Kind of went over the line there a little bit. Hopefully that doesn't throw you off too much. Really should not cross that line. All right, there's number 8. Okay, it looks like, what do we got over here? 9 through 10, write a linear equality whose graph is given. So before this, we were just graphing from the equation of the inequality that was given. Now we're kind of going backwards. So we're given the graph, and we got to come up with the inequality. So we're going to write these in slope-intercept form just to make it easy. So basically, we're going to identify the slope and the y-intercept, and then we'll talk about, whether or not it's solid versus dotted, and if you want to include those solutions. So number 9 has a y-intercept of -2, so it's going to be y equals mx minus 2, and then looking at the slope, it looks like we're going up 4 over 2. Up 4 over 2. That can be reduced. That's just going to be 2. So this would be like the equation if you were just writing the equation of the line, but this is an inequality. You can see that the shading is going up, and we have a dashed line here. Now in textbooks, they usually will just do all their dots solid. Not really sure exactly why. In my mind, it makes more sense to make them open dots. That's why I showed it to you that way. But they really focus more on the line itself rather than the points that they're plotting on here. I have my suspicions on why they do that, but it doesn't really matter. The point here is the fact that it's dotted here, the dashed line, is going to indicate that we don't want to include the points on the line as solutions. So because it's shaded up, we're going to say y is greater than 2x minus 2. Number 10 has a y-intercept of 1, and it looks like our slope going down 1, 2, 3, 4 over 2. That's going to be negative 4 over 2. We're going to have less than or equal to, because it is shaded down, and we do have a solid line. So negative 4 over 2 is going to reduce to negative 2x plus 1. And we can see the plus 1 is this, just the y-intercept right here. So number 11 has a y-intercept. It appears to be 1. Let's double check that. If the slope here is, see, going down 3, so down 4 over 4, then yeah, that has to be at 1. So yeah, down 4 over 4. So we're shading down. We have a solid line. So this is going to be down 4 over 4. This is actually just going to reduce to 1. Down 4 over 4, x plus 1. You don't really need this 1 here. You can get away without writing it, and it is implied that there's a negative 1 here. And that's pretty conventional. So we'll go ahead and stick with that. Here's your inequality. For 11. For number 12, we've got a y-intercept not very well defined here. It looks like it might be something like a half. So this is a case where we probably want to write this using point slope first and change it to slope-intercept form. So let's see. Y minus y1. So I'm going to use that 2, 1 point as my x1, y. Okay. So you could use either one, but I just think it's easier to go with the one that's positive. So y minus 1 equals, now let's see what the slope here is. Up 1, 2, 3, 4. So up 4 over 3. So 4 over 3 would be 4/3. That does not reduce, and that's probably why we're seeing this y-intercept not to be very nice. And then x minus 2. So here's our setup. Now it is greater than strictly, because we have a dashed line versus a dotted line. We could see the shading is up. Yeah, so anyway, let's finish this one off. Let's put it into slope-intercept form. We're going to start by distributing that 4/3. So just multiplying the 4/3 by everything in the parentheses. 4/3 times x is 4/3 x. And then 4/3 times 2 is going to be 8/3. And then finally, we want to add 1 to both sides. So we get 4/3 x. And then feel free to use a calculator on this last bit of arithmetic here. I mean, you could do it from the beginning, but negative 8/3 plus 1 be like negative 8/3 plus 3/3. So that'd be negative 5/3, which is like negative 1 2/3, which kind of jives with what we see on the graph here, right? It's a little bit more than 1, less than 2. So this fraction does make sense. And yeah, there you go. A little trickier because of the fractions, but that's going to be your inequality. Take a look at the next page. Number 13. With number 13 here, kind of looks like we're kind of going back a little bit, analyzing these word problems. This doesn't really look like it's going to be have a very high emphasis on the inequalities, which is what we've been working on so far, but we kind of covered everything. Hopefully now you can graph those inequalities. This is kind of just going back and giving you a little bit more practice with these stated problems. It says, Tanya works for a book publishing company, and this linear function describes her income when she has total sales X. So it looks like her income is based on 2 things. One is she gets $50,000, just I guess that's her base salary, and then she gets 1% of her sales. So we're multiplying her sales by 0.01. And so basically, I guess that's the incentive for her to work harder, is that if she makes more sales, she'll have a higher income. This says, what does f of 0 mean? Or what does it equal? So f of 0 is going to be what you get when you substitute 0 into the equation. So it would be 0.01, 1/10 times 0 plus 50,000, which, times 0 is not going to do anything. It's just going to make it equal to 0 plus 50,000. So f of 0 equals 50,000. Not really much to say about that one. But what does it represent in this context? Well, if this is her salary, that's how much money she's making without any of the sales or commission. So this $50,000 is going to be your base salary, and we want to say something to that effect. So f of 0, we'll say f of 0 equals 50,000 represents Tanya's base salary before commission. So commission just means like the amount of money you're making off of the sales, which would be that 1% of the sales before commission. That is, I guess, not how you spell commission. We fix it? Go. Okay, so that's it. In other words, she's going to make $50,000 even if she doesn't sell anything, although she might not be working there much longer. Okay. Part B says, what is Tanya's salary if she sells $500,000 worth of books in a year? So that's going to be her total sales, which is going to be the X. We're going to say F of 500,000. We're going to substitute in 500,000 here. And this is going to be something you're just going to want to put in the calculator. Numbers are kind of big, and it's not really worth the arithmetic error here. So yeah, just type that in, and we can get her salary. So we get the $50,000 plus, let's see, how much is she going to make? Looks like that's going to be, $5,000. So we're just dividing by 100 here. So yeah, it's going to be 5,000 plus 50,000, so she gets a total of 55,000. So this would be how you'd represent that algebraically if we want to just state it, answer the question in terms of how it's being asked. You can say Tanya's salary would be $55,000 if she sells, now this sounds like a lot of books, $500,000 in books. Right. Part C says, at what level of sales will her income be 65,000? So we will have to do a little bit of solving here because the question is asking, like, what's the X value? How much does she have to sell to get her salary to be that high? So we will leave this as X, but we want to set the equation equal to $65,000. This should just be X. And so here's just a little equation we need to solve. It's linear, so it shouldn't be too tricky. We're going to start by subtracting $50,000 from both sides. So it'll leave me with 15,000 equals 1/100th times X. And then we want to divide both sides by 1/100th. That would be the same thing as if we were going to, say, multiply by 100. And so we get, though, if we add 2 zeros to that, I guess we could type it in just to make sure. But I think it's $1.5 million worth of books. 2, 3, 1, 2. Yeah, that checks out. So it's a lot of books. Doesn't really seem like she gets that much of commission. I don't know how much a book salesman. If this is just like crazy, or if this is like Amazon, who knows? Anyway, Tanya needs to sell $1,500,000 in books to make $65,000. This seems like really excessive, but what do I know? I'm not a book salesman. It does seem like a lot, though. Maybe they're a textbook publisher or something. I don't know. Okay, no, that's it for number 13. Let's take a look at 14. Same kind of deal here. We're just playing with this function notation. says the annual cost of health insurance as a function of age is given by this function. I feel like there's a little bit of missing information here, but maybe not. Maybe that's just what it is. What is the health insurance premium of a 30-year-old? So we're going to plug in 30 here and say H of 30 equal to 22.8 times 30 minus 117.5. Yeah, let's just go ahead and throw that in the calculator, see what we get here. 566.5. 566.5. So the health insurance premium of a 30-year-old is going, and let's just go ahead and answer the question. Is $566.50. How reasonable is that? Nowadays, probably not very reasonable. Hard to say. Yeah, maybe. Doubtfully. It seems a little on the low side, at least in my experience. But you know, could be good. I don't know. That's the answer. So part B says, what is the age of an individual whose health insurance premium is $976.90? So this is a case where we'll set the H equal to that and solve for A. So we'll start this off by adding 117.5, both sides. It's going to give me 1,094.40 equals 22.8A. And then we're going to divide both sides by this 22.A. And that's going to give us A equals 48. So, as you get older, health insurance premium is going to go up. That does seem reasonable. Because if you're older, you probably have more health problems. So the insurance company is going to take that into account, obviously. Ugh. There. Okay, so I just want to copy this. Okay, so the health insurance premium for a 48-year-old is $976.90. Again, pretty expensive, huh? Insurance ain't cheap. Let's look at number 15. The weekly rental cost of a Class C 20-foot recreational vehicle is $129 plus 32 cents per mile. So first, they're asking us to write a linear function to express the cost as a function of miles driven. So the cost R, in terms of M, is going to equal 129 plus 32 cents per mile. The next question says, what is the rental cost if 360 miles are driven? So the rental cost, if 360 miles are driven, is going to be equal to 129 plus 0.32 times 360. So this one is just another calculator problem. As long as you have it set up right, it's going to be hard to get this one wrong. So yeah, we're just multiplying, adding. We'll throw that in the calculator. And the rental cost is going to be $244.20. Okay, so let's go ahead and answer this question. So the rental cost is $244.20 if 360 miles are driven. What I want to point out about how I'm answering these questions, notice how I'm not really being too creative about how I answer them. I'm literally just taking the question and rearranging the words so that I can give my answer as part of the answer to the question. So it says, what is the rental cost if 360 miles are driven? I'm saying, well, the rental cost is this if 360 miles are driven. Hopefully you see that I'm not being too creative here. You don't have to. You just kind of reword the question and inject the answer into it. Okay, so part C, How many miles are driven if the rental cost is $275.56? So this is a case where we will set the equation that we initially wrote equal to 275.56, and then we will solve for x here. So the first step is going to be to subtract 129 from both sides. That's going to be 146.56 equals 0.32 x. Then I'm going to divide both sides by 0.32, and so that's going to give me 458. Okay, so just like with the last statement, we want to make sure we are answering the question correctly here. If the rental cost is, and then let's see, it was $275.56 if 458 miles are driven. So part B is giving you the miles and you have to calculate the cost. Part C, they're giving you the cost and you have to figure out how many miles is associated with that cost. Number 16, our last problem here. In the North Chicago area, an 820 square foot apartment rents for $1,577 per month. I don't know if that's reasonable or not. I have no idea what the rental costs in North Chicago look like. Maybe that's right. A 970 square foot apartment rents for $1,660. Suppose that the relation between the area and rent is linear. Okay, so that means we could come up with an equation. So what I think I'll do first is figure out what the rate of change or the slope is. There's two coordinates that they're implicitly giving us. So like if I'm looking at like R and X, okay, so the rent is a function of the area. Okay, so we're coming up with an equation here. The rent is kind of like your y, and the area, well, they're giving you that as x, I guess as a little hint here. But we want to come up with the slope first. So 2 points here of note are 820 square feet. Cost is $1,507. And then the other coordinate, the data point, I should say, is 970 square feet, cost $1,660. So to write this equation, we do need to know the slope, okay, so that we can put it in point slope form, and then we can actually change it to slope intercept form. Let's figure out our delta y and delta x here, although we don't really have y, and instead we have r, but that's okay. So we're going to figure out what our change is here. We're going to figure out what our change is in x. This is going to be our delta, delta, not y, it's r, so I'm going to say delta r. And what would that be? 1660 minus 1507. Let's throw that in the calculator. We'll just subtract. That's going to be 153. Okay. Then my delta x here, from 820 to 970 is going to be 150. The rate of change, or slope, which, typically I write that as change in y over change of x. We don't actually have a change in y here. We have a change in r. But just so you can kind of keep track of what goes where, that's my change. It's sort of playing the role of change of y. And then my change in my independent variable x is going to go on the bottom. So it's going to be 153 over 150. Okay, and that might be worth just throwing in the calculator because that fraction doesn't look too friendly. I'm going to put that in. It's 1.02. Yeah, we're going to get some decimals here over to give us a little bit more space here. Okay, let's go ahead and write the equation, and I'm going to start with that point slope form, which, to remind you, is y minus y1 equals m times x minus x1. All right, so that's going to be sort of our template here. And we could use either coordinate to write the equation. I'll just start with the first one. They're both positive, so it's not really going to make a huge difference. So that x1, y1 is going to be, the y1 is going to be 1507. The x1 is going to be 820. The slope here is 1.02, and that's basically our function here. We want to write it in function form, though. So I'm going to kind of rewrite this so that we get it into slope-intercept form. So I'm going to start by distributing that 1.02. And now, hold on here. We don't really have y, do we? We have r. We change these y's to r. The x can stay x. There really is no y variable here. Y minus 1,507 equals 1.02x, and then we need to multiply 1.02 times negative 820. That's going to be 836.4. Or negative 836.4. And then finally here, we're going to take that number, we're going to add 1,507 to it. So we get r equals 1.02x plus, hold on here, I have to put this in the calculator. We got negative 836.4 plus 1,507. Okay, so I'm getting 670.6. I think that's right. That seems right. Is that right? Wait a minute. Yeah, I guess so. I think we're good here. Okay, let's go ahead and box. Now, actually, before I box this, we do want it in function notation here. So I'm going to say r of x equals. Okay, so there's our function. That's going to be how we're going to calculate the rent as a function of the area. So it says if the rent is $1,300 per month, I can't speak today. If the rent of the apartment is $1,300 per month, how big would you expect it to be? So we're going to take this function that we just created, and we're going to substitute the rent part of it with 1,300, and we're going to solve for x here. So first we'll subtract 1,300 minus 670. So here, 1,500 is going to be 629.4. And then if we divide both sides by 1.02, get about, right, 1,300 should be bigger, right? 9. What are we getting here? Oh, wait, no, it is smaller. It should be this. Yeah, I was looking at the number. Should be cheaper. Okay. Yeah, so we get 629.4 divided by 1.02, and I'm getting about, x is approximately 617.06. I'm rounding up that last decimal if you're following along with me. So yeah, that is going to be the approximate size. It's probably okay just to round to the nearest whole number because we're talking about square feet here. So about 617 square feet. So it's a little bit cheaper. It should be a little bit smaller. This number seems reasonable. Okay, so we're going to say that if the rent is $1,300, the area would be approximately 617 square feet. There you go. All right. So there is, that's it. Okay, so that pretty much wraps it up. So the first half of this homework was all about solving linear, or not even solving, but just kind of practicing graphing those linear inequalities. And then we had a little function practice here on the back end. So if you've hung in this long, thanks for watching, and y'all have a great day.